So we did our project on roots, and so we'll start off with the properties of the roots. The first property is product property, where you can just basically break down the A and the B into their own separate roots. And then there's the quotient property, which is it allows you to break up the roots into both the denominator and the numerator, and so you can both subdivide both it by themselves. And then there's the adding and subtracting, which is adding and subtracting. And there's multiplying, and multiply you just FOIL, and so you just take each one across individually, just like with normal exponents. Then for dividing conjugates, you just have to multiply the bottom by the reciprocal. But since you're multiplying the denominator, you also have to multiply the numerator. And then you just go from there.
Roots also have an irrational root theorem. So if x1 is equal to a plus square root of b, then x2 is equal to a minus square root of b. The nth roots is basically just finding the real number of n, which is the integer, which is multiple ways where you can use logs, but we weren't assigned that, so we can move on. That's about it. When a root is even, when an even root is of even power, the result is an odd number. You must use absolute values of the result, so it can't be negative. And when you're breaking down a root, you want to use this method right here to make it simpler on your life. And same goes for the x10, to break it down and simplify. Square roots can also be used as a root to a fraction, and fractions taken to a power mean to take the square root of that here. And that's how you do a radical form of the square root by dividing. You're able to break down powers in a root. And imaginary roots happen when the number underneath the square root is negative, so you will have to put an I that represents the imaginary root for graphing. That's it.
All right.